Imagine an object, the size of a city, hurtling through our solar system at a staggering 130,000 miles per hour. That's fast enough to cross the Atlantic Ocean in under 2 minutes. This isn't science fiction. This is 3I Atlas, the third confirmed interstellar visitor to our cosmic neighborhood, and it's acting very, very strange. On paper, it should just be another comet. But its trajectory is what has scientists on edge. It's on a path that takes it on a grand tour of our inner solar system, arcing past Mars, then Earth, then Venus, and finally Jupiter, all in a rapid, precise sequence. The odds of this happening by pure chance? Less than 0.005%. A statistical impossibility. This object is immense, nearly 20 kilometers across, making it the largest interstellar visitor we've ever recorded. To put that in perspective, that's the length of Manhattan, moving at a speed that dwarfs any known comet or asteroid. But it's not just the size and the bizarre tour that's raising eyebrows. It's also accelerating in ways we can't fully explain. So the whispers have started in the scientific community. Could 3I Atlas be more than just a rock? With its immense size, unexplained acceleration, and that uncanny four-planet flyby, some top scientists are asking the forbidden question. Is this a nuclear-powered reconnaissance craft sent here to test our response? If it is engineered, the stakes are off the charts. This could be humanity's first contact, and our response might determine the future of our species. What evidence could finally prove what we're really dealing with, and what happens next? Let's rewind to July 2025. This is when the numbers really start to paint a weird picture. Teams at the Rubin Observatory and using the TESS Space Telescope are tracking this object with incredible precision. They reconstruct its orbit, and it confirms a hyperbolic path, a one-way ticket through our solar system. It's not staying. But the data isn't a perfect fit. There are tiny deviations, subtle wobbles in its path that can't be explained by gravity alone. Now, for a normal comet, this isn't unusual. As they get closer to the sun, ice turns to gas and vents out in jets, nudging the comet slightly. But with 3I Atlas, the cloud of gas and dust around it, the coma is faint, and there's little evidence of these classic jets. And it gets stranger. As it tumbles through space, an object should flicker in brightness. The 3I Atlas's brightness is eerily steady. No spikes, no dips. It's moving with a near-mechanical consistency that defies natural explanations. At this size and speed, solar heating and venting gas should leave a signature, but the data is almost clean. Its velocity is so high that even after it escapes the sun's pull, it will still be traveling at one of the fastest speeds ever measured for a natural object. For some, this lack of a clear natural driver leads to a radical idea. Could there be an engine at work, hidden beneath that faint coma? The hunt for answers is on, pushing astronomers to dissect every anomaly in the motion of this Manhattan-sized interloper. By August 2025, the reconstructed orbit reveals the full, breathtaking scope of its journey. Mars, Earth, Venus, then Jupiter, all within 6 months. This isn't a simple flyby. It's a multi-planet circuit. It gets close enough for our telescopes to get a good look, but stays far enough away to avoid being captured by any planet's gravity. Think of it like threading a cosmic needle. It skims the orbital lanes of Mars and Earth, swings inside Venus's orbit, and then uses Jupiter for a gravitational slingshot to speed its exit. Orbital simulations confirm it. This alignment is an outlier among outliers. The odds against a random object taking this exact path are astronomical. One prominent astrophysicist, Avi Loeb, puts the probability at less than 0.005%. This figure starts a firestorm of debate. Critics argue it's just selection bias. We see more objects near the plane where our telescopes are looking. But even after correcting for that, the odds remain punishingly low. The choreography of this tour raises new questions. Is this a reconnaissance sweep designed to maximize viewpoints while minimizing risk? Each planet offers a unique window into our solar system. The sequence Mars, Earth, Venus, Jupiter seems optimized for observation without getting stuck. The path hints at intent, or at least a pattern that nature struggles to explain. The debate shifts from a physical anomaly to the possibility of purpose. If this is reconnaissance, what comes after observation? This is where Avi Loeb, the Harvard astrophysicist famous for his claims about Oumuamua being an alien probe, steps back into the spotlight. For Loeb, this isn't a coincidence. It's a sign of possible reconnaissance. He argues the odds are too slim for it to be random chance. His theory taps into a chilling concept from science fiction, the dark forest hypothesis. The idea is that the universe is like a dark forest, and every civilization is a silent hunter. To survive, you either stay hidden or risk being destroyed by anyone you reveal yourself to. If 3I Atlas is a probe operating under this logic, it would scan our solar system from a safe distance, gathering data without ever getting close enough to be intercepted. The flybys maximize coverage while minimizing exposure. Loeb even suggests this could be a follow-up to Gaumo's flyby in 2017, if that was a scout. Maybe 3I Atlas is a larger, more deliberate mission, arriving on a programmatic schedule? Of course, critics push back, saying the theory relies too much on coincidence, but the debate is on. Is this a peaceful survey? A test of our detection capabilities, or something more dangerous? But then, a different picture begins to emerge. Dr. Rachel Stevenson, a planetary scientist at JPL, analyzes the light coming from 3I Atlas. What she finds is familiar. The faint coma contains water, carbon dioxide, and organic molecules, the classic ingredients of a comet born in the cold darkness between stars. Images from Hubble show a hazy glow, but no sharp jets or metallic glints. Its surface reflects light like bright ice, not an engineered alloy. For Stevenson and many of her colleagues, the simplest explanation is the most likely one. It's a comet. A very rare, very large, and very strange comet, but a natural object nonetheless. Teams track the ratio of carbon dioxide to water, and it's among the highest ever recorded, suggesting it formed incredibly far from any star. Each new piece of data seems to ground the debate back in familiar chemistry and physics. But even if it's just a comet, it forces us to confront a critical question. What is our response plan? Engineers at Project Lyra run simulations. Intercepting an object moving this fast would require a velocity change far beyond our current rocket technology. We couldn't catch it if we wanted to. For now, we have to rely on telescopes, not probes. Policy advisors are dusting off the Outer Space Treaty. No unilateral signals, no nuclear devices in space. Everything must be subject to international review. Working groups at the UN and SETI are debating whether we should even try to send a message, or just stay silent, weighing the risks of contact against the cost of inaction. As 3I Atlas continues its sweep through our system, our response is being shaped not just by what it might be, but by how we choose to meet the unknown. This object, whether it's a natural wonder or something more, has challenged humanity to prepare, to cooperate, and to observe with open minds and open data. The great cosmic mystery continues, and we are all watching. Thanks for joining me on this deep dive into one of the most intriguing objects to ever visit our solar system. What do you think 3I Atlas is? Let me know in the comments below. And if you enjoy exploring the biggest questions in the universe, be sure to like this video and subscribe for more. See you next time.